Hello everyone and welcome to this lecture in the hands-on large language models series. In the previous lecture we started looking at a very important topic of large language models, and that is called as retrieval augmented generation. We looked at a simple demonstration of RAG and we also understood the fundamental principles behind RAG. Today we are going to quickly revisit some advanced RAG techniques. Before we dive into advanced RAG techniques, I just want to give you a brief demonstration of what RAG is so that it revises your understanding. So let me first erase this part. Right. So you can think of RAG as a search system and a large language model added at the end of the search system. Essentially what this means is, first you ask a question, then we have an algorithm such as dense retrieval which searches the database and then it retrieves the most relevant data sources. That's where the retrieval augmented comes into the picture. And then we pass the question along with the retrieved relevant documents to the large language model. So now the large language model not only has the question, but it also has the relevant documents. So that leads to responses which are more grounded in reality. That's why this is also called as grounded LLM generation. This is the reason why RAG also reduces hallucinations. The main reason why we reduce hallucinations is because we augment the generation process with retrieval of data. So that's why it's called retrieval augmented generation. So the simplest way to think of RAG is a combination of search followed by generation. And then we saw the open source and a closed source demonstration of RAG in the previous lecture. If you have not seen that lecture, I will highly encourage you to go back, look at that lecture, look at the theory, run the coding examples which we have demonstrated there. Today's lecture is specifically going to be about what are the advanced RAG techniques which have come out and which are still areas of active research, right? So the first technique which we are going to look at is called as query rewriting. What is query rewriting and why is it needed? Remember, what happens in RAG is that when you give a query, we have to go to our vector database. Let's say this is the database, and then we have to retrieve the top documents which are most similar to the query. So an essential component for this process to work is that the query needs to be written in a very easy to understand manner. The query needs to be very specific and it needs to be very clear. If the query is not clear, then the retrieved documents won't make too much sense. Let's take a simple example. Let's say this is the query. We have an essay due tomorrow. We have to write about some animal. I love penguins. I could write about them, but I could also write about dolphins. Are they animals? Maybe. Let's do dolphins. Where do they live, for example? You see, the problem with this query is that it's not very specific. It's a bit convoluted. So query rewriting takes queries like this and it converts them into an easy to understand format, such as where do dolphins live? Now if you look at this query, where do dolphins live, it is much cleaner, it is clearer to understand than the query on the left. Query rewriting can be done through OpenAI API. It can even be done through open source large language models where you just tell the large language model to take the query and rewrite it. It can also be done through closed source systems such as Cohere's API call, for example. I have found a very nice Google Colab notebook which takes in queries and rewrites them. So for example, if the query is what's going on with Airbnb's numbers, again, this is not a very easy to understand query, right? So your prompt can be rewrite the following user query into clear, specific and formal request suitable for retrieving relevant information from a vector database. Keep in mind that your rewritten query will be sent to a vector database which does similarity search for retrieving documents. And this Google Colab notebooks demonstrates this query rewriting through different ways. First, it shows how you can use GPT-4 API key to rewrite the query, how to use GPT 3.5 to rewrite the query, how we can use Mistral to rewrite the query, and ultimately how we can use Cohere to rewrite the query. But here you can see the prompt which has been given here is very detailed. The prompt says that the query needs to be clear, specific, because we need to retrieve relevant information from the database based on this query. So keep in mind that the rewritten query will be sent to a vector database which does similarity search. So our query needs to be concise and clear. This is the first advanced RAG technique. If your query is not clear, RAG will not be as efficient as it should be. So always keep this in mind. Always check whether your query is concise and clear. The second thing which also sometimes many researchers and students make a mistake is MultiQuery Rag. So let's say if the question or the query is compare the financial results of Nvidia in 2020 versus 2023. If you pass in the query and if you go to the vector database, it's very difficult to retrieve the relevant documents because there are a number of things to unpack within this query. First, you need Nvidia financial results of 2020. Then you need Nvidia financial results of 2023, and then you need to compare these two financial results. So the query in itself contains multiple things to unpack. In such cases, what we can do is that instead of making one search query, we can make two search queries. So the search query 1 can be Nvidia 2020 financial results, and the search query 2 can be Nvidia 2023 financial results. And then what we can do is that the search query 1 retrieves some relevant documents, search query 2 retrieves some relevant documents, and then we pass both of these retrieved documents to the LLM for grounded generation. On the other hand, if we just give this one query, it becomes very difficult to query the vector database itself. So always keep in mind that the query which you ask should have one objective. If it has multiple statements to unpack, it's always better to decompose the query into multiple subqueries. That is the second advanced RAG technique. The third advanced RAG technique is called Multihop Rag or Multihop Retrieval Augmented Generation. What does this mean? Let us understand this in detail. If the query is who are the largest car manufacturers in 2023, do they each make electric vehicles or not? Okay, so do you see here, again there are a number of things to unpack here. First we have to look at car manufacturers, right? Then we have to see which are the largest car manufacturers, and then we have to see whether those car manufacturers make electric vehicles or not. So to answer this question, the system must first search for, let's say within query 1, that's largest car manufacturer of 2023, and then after it gets this information, the result is Toyota, Volkswagen and Hyundai, let's say. Then we come to step number 2. So step 1 is done, where we first ask the largest manufacturers and we get the largest car manufacturers. Then we come to step number 2, and then within this step there are 3 queries. So step number 1 has just one query, step 1, but step number 2, let me mark this with a different color. Step number 2 has actually 3 queries which are associated with it. The query 1 in step number 2 is Toyota Motor Corporation, does it have electrical vehicles? Query 2 is Volkswagen, does it have electrical vehicles? And query number 3 here is Hyundai Motor Company, does it have electrical vehicles? So you see here the same query we have taken, we have divided it into 2 steps. In the step 1 we first ask the largest car manufacturers, and step 1 only has one query, and then in step 2 we have multiple subqueries. That's why it's called multi-hop RAG. This is different than multi-query RAG, because in multi-hop RAG, instead of multiple queries, we break down the query into multiple steps, and then each step itself can have multiple queries. So instead of passing one single query, a more advanced question may require a series of sequential queries. That's where multi-hop RAG comes into the picture. The fourth advanced RAG technique is called as query routing. So as has been mentioned here, an additional enhancement is to give the model the ability to search multiple data sources. We can, for example, specify for the model if it gets a question about HR, it should search Notion, which is the company's HR information system. We can say that if the question is about customer data, uh, the model should search about, let's say, Salesforce. So what's going on here is that once a query is being asked, you are being rerouted to either one of these data sources. So this is data source 1, data source 2, data source 3, and data source 4. You're rerouted to one of these data sources, and then you get the information from these data sources. So if it's a question about HR or hiring, let's say, you go to the company HR Notion document. If it's a question about, let's say, sales, then you go to the company's Salesforce document. Or if the question is what is the recruiting process within your company, you go to the Salesforce document, you find the recruiting process over there. So that's why this rerouting is very important. These different routes are the rerouting which is done after a query has been asked. This is called as query rerouting, or query routing rather. Query routing leads us to one of the most important and one of the most emerging advanced RAG techniques, and that's called as Agentic RAG, or Agentic Retrieval Augmented Generation. What Agentic RAG means is that, so here when a query is being asked, let's say we are directed to Notion, right? In Agentic RAG, we perform actions along with being directed to a certain application. So let's say instead of just accessing Notion, what if we give the RAG system the ability to write on this Notion? Or what if we give the RAG system ability to edit this Notion? That suddenly means that we have equipped the RAG system to perform actions, and that's when it becomes an agentic RAG. When a RAG system is equipped with tools, so let's say you have a RAG system and you equip it with tools such as, let's say, Notion is one such tool. Another tool is, let's say, a Python code interpreter. Another system is, let's say, payment booking. So these three are tools, right? Notion is a tool, Python code interpreter is a tool, and payment booking is a tool. Once you equip the RAG system with these tools, this RAG suddenly transforms into an agentic RAG. One example could be, let's say you want to execute an entire code in Python code interpreter, but you need some documentation. So what you do is that you create an agent, you make sure that agent gets the relevant documents of the code. These documents can come from dense retrieval. And then you can equip the agent with the Python code interpreter, and then the agent can execute the code. So this framework which I've shown in the green color right now, that is an example of agentic RAG. Why agentic RAG? Because first of all, we have RAG since we are giving relevant documents, so we are grounding the output of the agent. And the reason it's called agentic and not just LLM is that an LLM, when it's equipped with tools, it becomes RAG. An LLM, when it's equipped to perform an action, it becomes RAG, or it becomes an agent, sorry. An LLM, when it's equipped with tools, becomes an agent. An LLM, when equipped to perform an action, becomes an agent. So here, the LLM can perform action, so it can directly run Python code, right? That's why we are calling it an agent. So agentic RAG is that section, or that advanced RAG method which is becoming very popular. In fact, there is a lot of investment flowing into this space, a lot of research which is being done in this area. Most of the lectures in the hands-on large language model series are inspired from this book, Hands-on Large Language Models by J. Alamar and Martin Grothendorst. So here you can see the authors, what they have written. So the authors have written that you may be able to now see that the list of previous enhancements slowly delegates more and more responsibilities to the LLM to solve more and more complex problems. This relies on the LLM's capability to gauge the required information needs as well as its ability to utilize multiple data sources. This new nature of the LLM starts to become closer and closer to an agent which acts on the world. The data sources can also be abstracted into tools. We saw for an example that we can search Notion, but by the same token, we should be able to post to Notion as well. So then suddenly we start doing actions by being equipped with tools. And then agents, then LLMs become agents. RAG systems become agentic RAG systems. So as we head into 2025, 2026, people are saying that this is going to be the year of agents because LLMs are now being equipped with tools so that they can actually perform real world applications. And when those LLMs are grounded in reality through documents, then they suddenly become RAG systems. So that's why it's called Agentic RAG. So as a recap, we covered 5 methods today. The first is called query rewriting. The second is called MultiQuery Rag. The third is called Multihop Rag. The fourth is query routing. And the fifth is Agentic RAG. One more thing I want to mention is that many companies around the world are already starting to introduce Agentic RAG into their pipeline. So for example, if you search Command R+, you will see that Cohere has released Command R+, which is an Agentic RAG, which helps businesses interface with their several softwares or several tools which they use. You can expect many such tools to come out in the next year or so. So a lot of innovation and a lot of work is still being done in the Agentic RAG space, and I am particularly excited about what comes out in this area. So thanks a lot everyone for watching this lecture. In this lecture, we built on top of our understanding of RAG. In the previous lecture, we understood RAG and we implemented code. In this lecture, we took it to the next level where we understood advanced RAG techniques. These techniques can help you once you understand the fundamentals of RAG and now you want to deploy RAG techniques in practice. So always keep these advanced techniques in mind, especially Agentic RAG. In the next lecture, we'll be looking at evaluating RAG systems, and finally we'll see a summary of what all we have learned in semantic search and RAG. Thanks a lot everyone, and I look forward to seeing you in the next lecture.